Finding the median of a set of data is usually very straightforward. We use this little formula, n plus 1 over 2, and it shows us the position of our median within that data. Then we just have to count from one end or the other to find the median so we can identify it. But when we have what's called class data, this situation becomes a little bit more complicated. Class data is when the data is broken into classes such that you don't know exactly what all of the individual data points are. Here I have a table that shows the number of years of marriage of 101 couples. We have surveyed the 101 couples and we have found that there are 29 couples who have been married for somewhere between 0 and 10 years. 40 who have been married between 10 and 20 years, etc. So the data is broken into classes, and we want to know the median of this data. First we do our usual median formula, n plus 1 over 2. Since there is a total of 101 couples that have been surveyed, I am writing 101 plus 1 over 2, which is equal to 102 over 2, which is equal to 51. That tells me that the median is not 51. It is the 51st data value out of the 101 that have been collected, if we list the data values from the lowest number to the largest. The next thing that we want to do is we want to figure out which of these classes our median falls into. One of the things we can do to make this easier is if we add a column to our table that is the cumulative frequency. It just means the frequency of data that has been collected so far up to that point in the table. So in the first class, there are 29 couples that have been surveyed and that are found within this class. The cumulative frequency, the total that we have so far, is 29. But if we add the 40 from the second class, our cumulative frequency becomes 69. There are 69 couples who have been married between 0 and 20 years. That's what that means. Adding the 22, we have 91, and then adding the 10, we have 101. And our sample size we always knew was 101. So this makes sense. Since the median is the 51st of these data values, there's no way the median can be one of these first 29. But once we get to the cumulative frequency of the second class, we have gone past the 51st value, we have reached 69. So what that tells us is that the 51st data value, which is our median, is somewhere in this class. This is our median class. Because it has to be larger than the first 29 values, but it has to be smaller than the 70th value, which would be down here. So we have identified our median class, and it is the class 10 to 20. This tells us a lot of the information that we need in order to calculate the median of this data. The next thing that we have to calculate is our R value. R stands for rank. It means the rank of the median within the median class. We have already determined that the median class is this one from 10 to 20, which means our median is one of these 40 values. But which one? How many of these 40 values lie below the median, and how many lie above it? That will tell us our rank, where the median actually ranks within these 40 values. And the way to find our R value, our rank, is to take the result of the n plus 1 over 2 that we did before, our 51, and from it we subtract the cumulative frequency of the previous class. So now we have another reason why we want this cumulative frequency information. It's the previous class's cumulative frequency that we care about. The median class is 10 to 20, the previous class is the 0 to 10 class. It's its cumulative frequency that we need. So we are subtracting 29, and the answer is 22. Now, finally, since we have this information, we know what our median class is, and we know the rank of our median within that class, we have enough information to fill in our median formula. This formula is only used for class data, and it's very easy to use once we have done this work to set it up. Median is equal to L sub I is the lower limit of the median class. Since this is our median class, its lower limit is 10, so we replace our L sub I with 10. The rank is this 22 that we found before, and the frequency is the frequency of the median class, which is this 40. And we're doing times W. W is the width of the median class, but that's the same as the width of all of the classes. The width of the classes in this table is 10, so we put a 10 here. Now all that is left for us to do is to follow the rules of BEDMAS to simplify this expression, and we will have our median. First thing we have to do is 22 divided by 40, which is 0.55. I'm going to move down here to finish off my calculations. The next thing that I have to do is this multiplication. 10 times 0.55 is equal to 5.5. And finally, 10 plus 5.5 is 15.5. So our median for this data is 15.5. And we could say 15 and a half years is the median length of marriage for these 101 couples. Now this has to be an estimate because we don't actually know the data here. We don't know exactly how many of these couples, for instance, were married for 2 years and how many were married for 3. So this formula, by necessity, is an estimate of the median. Still, for class data, this is how to find our median, and this time it is 15.5.